Did you know that the energy released in a fully developed hurricane is equivalent to launching 10,000 space shuttles? Absolutely mind-boggling, isn't it? And as we prepare to whisk you away to our next scene, here's a quick reminder. Don't forget to subscribe to our channel and push the bell icon for more such enlightening videos. So, how exactly does nature muster such a prodigious force? Imagine this. The ocean, like a large pot of soup, heats up under the tropical sun. When the water temperature hits around 27 degrees Celsius, conditions are ripe for a hurricane. Now, picture a small disturbance in this warm tropical ocean, akin to a spoon stirring the pot. This initial disturbance, often near the equator, is the first step towards a hurricane. As the disturbance grows, the Earth's rotation steps in and adds a twist. Due to a phenomenon called the Coriolis effect, the air near the surface starts spinning. It's like a giant invisible hand stirring the pot in a counterclockwise direction in the northern hemisphere and clockwise in the southern hemisphere. Next up is convection. Think of it as steam rising from your hot soup. The warm, moist air rises, cools down, and transforms into clouds. This process releases heat, which is like adding more firewood to the stove, further fueling the storm. Then comes the eye of the storm. Picture a calm, clear spot right in the middle of your swirling soup. This is the eye, a peaceful-looking center, surrounded by the most intense part of the storm. It's deceiving, like the calm before the storm, but in this case, it's the calm within the storm. With the continuous heat from the ocean acting like a power plant and the release of heat from convection, the winds pick up speed. They form spiraling rain bands extending outward from the eye, like ripples spreading out when you drop a pebble in a pond. Finally, when the winds sustain a speed of 74 miles per hour or more, the storm earns its title, a hurricane, tropical cyclone, or typhoon, depending on where it is in the world. While this is a simplified version of a complex process, it serves as a basic understanding of how hurricanes form. The actual process involves a myriad of atmospheric and oceanic factors that weather scientists are still studying. And why does this matter? Because understanding hurricane formation is crucial to predicting their paths and intensities, which in turn helps in issuing timely warnings and saving lives. So the next time you hear about a hurricane brewing, remember the pot of soup, the invisible hand, and the importance of understanding this awe-inspiring force of nature.